welcome back, and let's get on with the algebraic approach to determining the inverse of a function. Okay, this is again going to be very short. It is just a concept that once you get the hang of, it becomes very easy to determine inverse functions. Okay, so here is the idea. I'm taking you back one more last time to our function machine. And this is just to get you understanding the main concept behind this. All right, so we know that if we have a function f and we place in a number, let's say 2, and suppose we get a 1 or whatever it is, right? So here is a function such that when we put 2 there, we get 1. Okay, we expect that when we put 1 from the below, we get 2 at the top because that would be the inverse, right? So 2 is the input and 1 is the output. Okay, similarly, if we put an x, if we put x in there, we expect to get a y or f of x. Okay, the reverse process, which we refer to as the inverse process, requires that, and this is the whole idea, that we know that if for this function here, it's f such that if we put x, we should get a y on the other side. And we write that y is f of x, all right? The reverse process is a process in which the input is now y. So y becomes our input. So let's look at the reverse process. This is now going to be our inverse function, okay? Now this time we put a number down there and we expect to get a 2 because when we put 2 there we got 1 here. So when we put 1 we expect to get 2 at the top there, okay? And similarly, if we put x at the bottom, or if we put y, then we expect to get x on the other side. This is the idea really. So if we put y, now y is our input, our output is going to be x. So in the function, we put x, we expect to get y. In the inverse function, we are reversing the process and putting y in order to come up with x. This is what we are going to use. So if this is the process or the path for the function, then the path for the inverse function has to be that f inverse is such that when you put in y, you should get x. And this is really it. This is all we need to know. It means that, so we have x equals, so you can see now we have x equals f of y because y is now our input. In fact, what has happened between a function and its inverse is that we have simply replaced y with x. We have swapped the value of y and x when we are determining the inverse function. So when you compare a function and its inverse, the difference is that in place of y, in the inverse function, x takes the place of y, and y takes the place of x in the original function. This is very important in determining the inverse function algebraically. So let's look at an example of what we are talking about. So the algebraic process involves, if we want to determine the inverse function, the first step is simply to swap the input. Okay, so where swap x with y. So where there is x, put y, and where there is y, put x. That's the first step when you're looking for the inverse of a function. The second step, okay, so here we go. So where there is y, we will put an x, and where there is an x, we will put a y. That's the first step. All right, the second step is to make y the subject of the formula. So once we've swapped x and y, we now rearrange the formula using our understanding of a subject of formulae, and we make y subject of the formula. And then once we've done that, we remove that y and replace it with f inverse of x. That will become our inverse function. Here is an example of what I'm talking about. Okay, so find the inverse of f of x is 3x minus 1. So the first step, before I go into that first step, please remember, I want to make this look simpler. Remember, f of x means the same thing as y. So I can first of all remove that f of x and replace it with y as Bozo says there. Okay, so replacing that just to make the writing a little look a little simpler, we will replace f of x with y because they mean the same thing. So now y equals y equals 3x minus 1. Okay? Now we can perform this step here, and we say that we are going to swap the value of y and the value of x. If we do that, swap them like that, and then simply make y the subject of the formula. So now we have an expression x equals 3y minus 1. We are going in the reverse direction from our function machine, if you remember. So if we make y the subject of the formula, that means moving -1 to the other side, it becomes x plus 1, and we are left on this side with 3y. And now we need to divide through by 3 so that we are left with y. We are making y the subject of the formula according to this. So if we divide both sides by 3, we have x plus 1 over 3 equals y. This is our inverse function, but we cannot leave it like this, otherwise we are penalized. So we have to remove that y and replace it with a symbol for inverse function, and so we can write that f inverse is x plus 1 divided by 3, or a third x plus 1. It's as simple as that to determine the inverse of a function. Okay, let's look at some more worked examples. Here is a question: find the inverse of each of the following functions. Here is the first one. Remember that the square root of x minus 4 is the same as x minus 4 to the power of a half. Okay, we want to find the inverse of g of x there. Then we want to find the inverse of h of x and the inverse of the function k of x. So let's start with the first one. So remember, the first step is to replace f of x with y. If it is not already y there, sometimes the question will have y instead of f of x, in which case you just move to the next step. So once we've replaced it, so in place of f of x we have y, the next step is to swap x and y. So where there is y, put x, and where there is x, put y. So that gives me x equals the square root of y minus 4. Okay? Now, how are we going to make y the subject of the formula? You can pause the video and think about it and even try it. Okay? Well, the step is we have to get rid of the square root sign, and the reverse of the square root sign is the square. So that requires us to square this. But if we square the right-hand side, we must also square the left-hand side. So if we do that, we get x squared, and now the square root disappears on the right-hand side. We end up with, maybe I should have done that step first before moving on. So we get here, we end up with x squared equals y minus 4. So squaring both sides ensures that the square root sign disappears. This is minus, so when we move it to the other side, it becomes a plus. And so that is the inverse function of that function f of x. Okay? Let's see another one. Here is another one, g of x. Find the inverse of g of x. So again, replace g of x with y. Okay? We have, once we replace that, we have y is 4 minus x over x. Swap x and y, we get x. Okay, so when we swap the variables, we get x equals 4 minus y over y. Make y the subject of the formula. To do that, we need to cross multiply, make this be over 1. So we have here now, this is x over 1. So if we cross multiply, we get xy equals 4 minus y. Okay, we are trying to make y the subject of the formula. I'll use this space here. Okay, so I will have x times y. This y goes to the other side and becomes plus y equals 4. Factorize y out. We have y into x plus 1 is 4. Now we divide both sides by x plus 1, and that gives me y is 4 over x plus 1. And this is our inverse function, so we only need to write, it was g of x, it wasn't f. So now we can go back and write g inverse. So now g inverse of x is simply 4 over x plus 1, like that. And we have determined the inverse function. It is pretty easy, but you have to keep practicing so you do not forget what you've understood. Usually in mathematics, stuff that is easy to understand is also very, very easy to forget. Right, so we found this. The inverse function becomes that. That is our inverse function, okay? Question number 3, h of x is 2x power 5 plus 1, right? Replace h of x with y, okay? We have y is 2x power 5 plus 1. Swap the variables, x and y. So where there is y, put x, and where there is x, put y, like that. Now make y the subject of the formula. To make y the subject of the formula, this is 2y, this is 2y power 5 equals x, and positive 1 goes to the other side, becomes minus 1. Okay, next step, we have to get rid of the multiplication, so divide both sides by 2. I get y power 5 equals x minus 1 divided by 2. And now y power 5, we need to get rid of the 5. To get rid of the 5, we find the fifth root, or multiply by 1 over 5, okay? So if I multiply by 1 over, take the power of 1 over 5, in other words, y power 5, power 1 over 5, that's the fifth root, is the same as x minus 1 over 2 power 1 over 5. And it's better to write like this than writing the fifth root like that. Aesthetically, this is better than using the radical symbol, which sometimes can be untidy in mathematics. Okay, and so our inverse, so y power 5 power 1 over 5, this cancels off and we are left with just y. And so this is our inverse function right there, power 1 over 5. Okay, just like that. And that is the inverse function. We just need to show it there now. So hopefully you've seen the process, especially this, those who've not studied indices, or you have done it but you've not looked at power indices where the indices or the exponents are fractional, are fractions as opposed to whole numbers. I hope you will understand that. Otherwise, put it in the comment and I can add something to try and help you. Alternatively, you go to the earlier topic 1, videos on topic 1 and exponent. This will be discussed there. Okay, and so what we've just done, made y the subject of the formula. You can see what I've come up with, and that is what we get for the inverse of h of x. Question number 4, this is quadratic in vertex form. So once again, replace k of x with y. All right, we have y is that. Then swap the variables just like before. We get x equals into bracket y minus 2 squared plus 3. Our job is now to make y the subject of the formula. We must start with by taking 3 to the other side. We get x minus 3. Okay, so x minus 3, I've skipped steps. So it's basically that goes to the other side. Let me go back slightly and do this. So we get, I'll use a different color. So the 3 goes to the other side. We have x there minus 3 is y minus 2 squared. Now to get rid of the square, we take the square root of both sides. We have y minus 2 equals the square root of x minus 3. We are taking the square root of both sides in order to get rid of the square. So the inverse of the square is the square root. That's why we have to take the square root of both sides. And now all I need to do is take these two to the other side, and I have y equals positive 2 plus root of x minus 3. That's really it. And so I can say my k inverse of x is 2 plus root of x minus 3, like that. And that is the inverse of the function k of x here. Yeah? Okay, let me just put those answers. All right, so we took 3 to the other side, it became x minus 3, and then found the square root of both sides, so we are left with y minus 2 and square root on that side, and then you move the negative 2 to the other side, and you have y which is 2, y which is, I've skipped some steps now, k inverse is 2 plus the square root of x minus 3. That's how you solve those questions. Now here are some problem set for you to try out. Let's see what you come up with. Please try this, and let's see, we will go through the answers with you once this is done. So we'll do a video on the solution of these questions next, before we go to the next part. Okay? These are your questions. And I believe, now this is in orange because it is a logarithmic function, and some of the students, especially in MYP 5, IGCSE, you may not have gone into the logs. If that's the case, then you can ignore the 5th question there. Otherwise, please try it out. Let's see what you end up with. I believe then that this is the end of this video. I'll see you for the next. We'll try to go to graphical method or the graphical approach to determining the inverse, and then after that we will tackle the questions all together for the inverse functions. Thank you for watching this video. Let's meet in the next one. Thank you and bye.